Welcome. Multiplying decimals. That's what we're looking with today. So let me set up a problem for us. All right, we have 0 and 7/10 times 3 and 2/10, or 0.7 times 3.2. I want to show you a similar problem that you probably already know how to solve. Here it is, 7 times 32. Now look at this one here on the right. Do you feel that you could solve that? Is that something that you know how to do already? If it is, you're in luck. You are already going to know how to solve this one with one simple thing to add in there, and that's what I'm going to show you in this video. So here's the good news. When we're multiplying decimals like this, we can solve the whole number version, that's this over here, and get the same number answer. Then all we have to do is figure out where the decimal goes in our answer. And before we jump into that, I just want to make sure that that makes sense, because this is the critical part of multiplying decimals. Look at the numbers that we have here. Compare them to the numbers that we have here. Would you get the same numbers in your answer? Now, sure, we're going to have a decimal that goes somewhere in our answer down on this one, and we won't have that in the same way here. But the numbers in our answer, are those going to be the same? Yes, because we multiply in the same way. This one will start with 2 times 7 and go to 2 times 0. And this one over here would do the same thing with 2 times 7. There is no 0 there, but what's 2 times 0 anyway? It's 0, which means that it won't even change our answer down there. So for a super quick warm-up, let's solve this one. 2 times 7 is 14. If I had another digit up there, then I'd put it there. Okay, since we have a second digit here, we add this 0 to scoot the place value over one spot. That's the critical part to remember when you have multiple down here. Now we can do 3 times 7, and that's 21. Let's add these up. 4, 1 plus 1 is 2, and 2, 224. Now I have some great news. These will be the same digits that will be in our answer up here, but we're going to have the decimal to deal with. All right, let's make sure we've got place value remembered. This would be a 1. How many are there? There is 1 of it. And the next place value over this way is what place value? It's the tens place value. How many do I have? Well, I've got 10 of those. And then there's a decimal right here. The next place value to the right is the tenths, which means you are taking tiny little slivers, and the important thing is that each of those little pieces would have to be the exact same size, which is tricky for a circle, so we usually show it with a different shape. So this is the tenths place, and to show that it's different from the tens place, we add the th right there to show us that difference. So earlier in our previous problem, we had the number 0.7. Now, what place value is this 7 in? Is it in the tens, the ones, or the tenths place? Well, it's one spot to the right of the decimal, which puts it in the tenths place. So this 7 means there are 7 tiny pieces out of 10, so it's almost one whole, but it's not quite one whole. Now here's the important thing with multiplying decimals. Does 7/10 equal 7 ones? Or if you had 7 tiny fractions of this circle, would it equal the same as 7 whole circles? Well, no. So that's why we have to be careful with the decimal place when we're multiplying decimals, to make sure that in the end that we have pieces of the right size. So all right, let's multiply this out. We've got 2 times 7 is 14. I do put the 1 up here because I have 2 times 0 is 0 plus 1. Hey, it looks the same so far. Now this 3 is the next place value over, so we scoot it over with the 0 so that our first digit down below in the answer will be over one place value. 3 times 7 is 21, so I put the 1 down here, and I need to be careful that I don't get confused about this one that I've already drawn. This is my 2 up here. So now I have 3 times 0 plus 2, and that's going to be 2. You'll notice that these are the same. That's great. 4 plus 0, 1 plus 1 is 2, and 2. Now, should these have the exact same answer? No. They should have the same digits. By digits, I mean those exact numbers, 2, 2, 4. But Is 32 ones, 32 wholes, the same as 3 2/10? Just to review, is 32 of these the same as 3 2/10 of those? No, it's not. So we've got to show that. And we show that with our decimal place. So here it is, the big trick of all. It's not so hard, actually. How many place values do we have in our multiplying numbers, in our factors, to the right of the decimal? We're going to add all of them up. We have one place value to the right here. And on this number, we have one digit to the right of the place value. So we have 2 to the right of the decimal. Well, here's where my decimal would be. This is how many times I scoot over my decimal. I'm going to scoot it over 2 times. So this correct answer would be 2 2400ths, or 2.24. And let's see if that makes sense in our minds. We have something that's about 3. We're going to do some estimating. This is about 3 right there. And if I have 3 of something, this 7/10 means I'm going to take most of it, but not quite all of it. By just a little bit, but it's going to be most of it. So if I was to take most of that, well, it'd be something around, 2 is most of it, and maybe a little bit more right there. Let's check our answer. And our answer is 2 and a little bit more, so that makes sense. So there's the secret. That's how you do it. Now I'm just going to show it to you a few times in a row so that you can get confident with it. When you're ready, you can move on to tackle problems like this. Here's my next one. 1 1700ths times 4 9/10. Let's multiply it as if it was this problem here. We will have the same digits in our answer in both spots, and then we'll figure out where to place this decimal point at the end. We begin with 9 times 7. 9 times 7 is 63. The 3 goes down below and the 6 up above. 9 times 1 is 9. Plus 6 is 15. The 5 goes here and the 1 up there. 9 times 1 is 9. Plus 1 is 10. And I put both digits here since there aren't any more there to multiply. All right, what's the all-important next step to multiply this 4 correctly? It's one place value over, so we put a 0 here to shift all of its answers one place value over. That keeps our pieces the right size in our answer. 4 times 7 is 28, and the 2 goes up here. Be so careful to not get confused at this very step. 4 times 1 plus 2 is going to be 6. And 4 times 1, I don't have this now. It's just 4 times 1 is 4. Let's add these pieces back together to get one final answer. We have 3 plus 0. 5 plus 8 is 13. 1 plus 0 plus 6 is the same as 1 plus 6, and that's going to be 7. And 1 plus 4 is 5. All right, now let's think about this. This number is about 1. It's about 1. And this number, the closest whole number, is 5. So we have something similar to 1 times 5. And I'll write it this way just so we can see it normally. 1 times 5 is 5. So our answer should be about 5. As we look at it right now, is our answer about 5? No, it's over 5,000. That's very different. Picture 5,000 pennies or just 5 pennies. That's not the same at all. But that's because we haven't brought down the decimal to our answer. And here's how you do it. How many digits are to the right of the decimal in all of the numbers? 1, 2, 3. And starting on the right, that's how many times we come over. 1, 2, 3 spots. And our decimal goes right there. 5 733 thousandths, or 5.733. Let's compare to our estimating. Our estimating said about 5. And this answer, 5.733, is about 5. We did it. Great job. Let's see another one. All right, in this one, we have 64 2/10 times 7/100. Let's solve it as if it was this problem, 642 times 7. Our digits in the answer will be the exact same, and then we're going to scoot our place values over to make it the correct amount. And if this video is helping you out, you can help me out by giving it a thumbs up. 7 times 2 is 14. 7 times 4 is 28, plus 1 is 29. The 9 goes here and the 2 goes up above. 7 times 6 is 42, plus 2 is 44. As I look here, this next digit is a 0, so all of my digits would be zeros. And this one as well, we'd have zeros all the way over, regardless of how many. It's not going to change the amount. So I'm going to go ahead and take these zeros back out just to simplify it. I'm done multiplying. There are my numbers, but let's figure out about how big this should be. And for that, estimating is a great tool. So I'm gonna round this to the nearest 10, 60 or 70. It's closer to 60 because of this 4 right there. And then 7 hundredths is a tiny amount. That's as a fraction like this. So I'm gonna show you a cool way that you could estimate this. If it doesn't make sense to you, that is just fine, but see if you can follow along. This fraction right here is the same as multiplying by 7 and dividing by the denominator, dividing by 100. Dividing by 100 is the same as scooting the decimal over 2 spots. So that becomes 0.6, and then we have a 0.6 times 7. That's the same as 6 times 7 with 1 decimal place, 4.2. So our answer should be around 4.2. And 4,000 is not it. So where should it go? Right here's looking good. But let's confirm it. How many digits do we have to the right of the decimal? 1, 2, 3. We start on the far right side and go over 1, 2, 3. It's confirmed. We counted the exact digits and estimated to find about how much it should be. This exact answer is 4 and 494 thousandths, or 4.494. Well done. And I've got one last example for you. Okay, it's our biggest one yet. Let's see what we can come up with. I'm going to solve this as if it's 805 times 522, knowing that my digits will be the exact same, and then I can place the decimal at the end. 2 times 5 is 10. 2 times 0 plus 1 is just 1. 2 times 8 is 16. Here's the step that can be easy to forget. For this next one, my answers need to be over one place value because this digit's over one place value from that too. So this 0 scoots it over. Now we have 2 times 5, and I can use that 1 again. 2 times 0 plus 1, and 2 times 8 is 16. Hey look, those are the exact same because those are the exact same. This 5 is 2 spots over, so 2 zeros right there. 5 times 5 is 25. Carefully cover that one to write my new one. Erasing that completely is even better. 5 times 0 plus 2, and 5 times 8 is 40. All right, I'm going to add these up. Zeros here, 1. 6 plus 1 plus 5, I'll give you a moment, is 12. So I carry the 1. 1 plus 1 plus 6 plus 2. It's going to be 10. 1 plus 1 is 2, and just a 4. So fantastic. We have our correct digits, but we need to move the decimal. It's not actually 420,000. So let's check with estimating. This number is about 8, and this number is about 5. So our answer should be about 8 times 5, or 40. Also, exactly, it should be 1, 2, 3, 4 decimal spots over. This 0 does matter. We can't just erase it, because if we start counting from here, that's not what we actually had in our answer. So we do include this 0, because that's what we added. 0 plus 0 plus 0 is 0. So our decimal starts here, and we go over 4 spots, because we have 4 digits after decimals in the factors. 1, 2, 3, 4. Let's confirm it. Our estimating said it should be about 40. So I'm going to rewrite it. 42. Now we can drop this last 0 because we're not counting off of it. So 42 and 21 thousandths, or 42.021. We did it. I'm so proud of you. Thanks for sticking with me. You know how to multiply decimals to tenths and hundredths now, And the process is the same into the thousands and 10,000s and beyond. It just gets really long and hard to keep track of everything. But the steps are the same. So if this helped you, give it a thumbs up. And you are now ready to tackle problems like this. Good job.